With the polynomials that we're going to be dealing with here, the first thing that we're going to start dealing with are the rules of exponents. The rules of exponents. And what I'm going to do is I'm going to have the rule on the left and kind of a generic example in the middle, and then an actual kind of, here's a problem like what you'll do with this rule on the right. So you'll have kind of three columns out of that. So an organized little chart here for the rules of exponents. The first rule that we'll talk about, and probably the most common rule for polynomials, is the product rule. And the product rule, you got to remember, is add. And product in math is multiplication. So when you're multiplying two things that have the same base and have exponents, the rule is that you add the exponents. Okay, multiply the base. Remember, is this part down here? That's the base. So the bases have to be the same. And if you're multiplying, you add the exponents together. So an example, like a working example of something that you would do that with, might be something like x to the fifth times x to the third. And you would, they have the same base. The bases are both x, so that means they're the same base. So the rule is, if the bases are the same, then you add the exponents. So the final answer would be x to the 5 plus 3, which is 8. So multiplication, add the exponents. Multiplication, bases are the same, add the exponents. That's what you want to do, the product rule for rules of exponents. It's not necessarily important that you remember the name of the rule, just how it works. Okay, product rule, multiplication, add exponents. That's what you got to remember. Don't necessarily focus on trying to remember. The product rule says this. Just know, hey, if it's multiplying and the bases are the same, add the exponents. The next one is the power rule. The power rule, the idea is to multiply the exponents. And the power rule, the way it works is you got some number or some base with an exponent, and it's got parentheses in it. So when you see parentheses and then an exponential type thing, then that's what tells you, hey, I've got to multiply the exponents. Parentheses, power rule, that's multiply. Okay, an example that like this one might be something where you might maybe have x to the 6th power. It's in parentheses and it has a squared on the outside. The rule is that you would multiply those exponents. So x to the 6th, and then you say that to the second power. Well, that's going to be x to the 6 times 2, which is x to the 12th power. You multiply those two exponents there. So parentheses, you see those, you're going to think, oh, I need to multiply exponents here. All right. Another type of power rule that could happen would be something where maybe you have more than one thing in the parentheses. Maybe you've got a to the m power, b to the n, and then some exponent on the outside. Everybody, it's like distributed property. Everybody gets multiplied by this x power. So it's a to the mx, b to the nx. An example of that would be something like maybe you got x to the 3rd, y squared, and it's all to the 4th power. So that'd be x to the 12th, y to the 8th. So 4 times 3 is 12. 4 times 2 is 8. So that's how that ends up being that. Okay. So multiply any exponent on the inside times the exponent on the outside if there's parentheses there. Another power rule that could happen would be if you've got a fraction on the inside of the parentheses. Maybe you got something like a to the m over b to the n. Same thing, everybody gets multiplied. So it's a to the mx over b to the nx. An example of that might be x to the 7th over y to the 4th squared. So that'd be x to the 14th. 7 times 2 is 14. 4 times 2 would be y to the 8th. So power rule, anytime there's parentheses, that's when the power rule is going to come in. Okay, parentheses, that's how you know to multiply exponents. If it's just multiplying, that's a product rule, and you're going to add exponents. So multiplying the exponents comes with parentheses. And the last rule, there's only 3 of them that we got to deal with, is the quotient rule. Quotient means division. Division is the opposite of multiplication. So when we multiply, we add. The opposite of multiplying is dividing. So when we divide, we're going to subtract. Might have a to the m over a to the n. You subtract the exponents. The bases have to be the same for you to do this. Okay, the bases are different. You can't do it that way. So example of that, excuse me, might be x to the 13th over x to the 5th. 13 minus 5 would be 8, x to the 8th. My 8's not looking like 8. 13 minus 5 is 8, so that'd be x to the 8th power. Top minus bottom, always. Always top minus bottom. Okay, so working those rules to simplify expressions is what we're going to be doing here. So let's look at some examples that kind of mix in some of the other stuff that we did with order of operations and things with that to simplify here. So that's what the instructions are going to say. They're going to say simplify. And first example might be straight up y to the 6th times y to the 5th, which is absolutely just a product rule. The bases are the same. They're both y's. We're multiplying, so we add the exponents. So it'll be y to the 11th. Real simple, straightforward, exactly what the rule is. Where they kind of can start mixing it together is when you might have 3x to the 3rd times 4x to the 5th. Well, now you got numbers in the front. Don't let that confuse you. It's still a math problem. It says 3x to the 3rd times 4x to the 5th. The numbers in front do the same math they've always done. It's 3 times 4, which would be 12. And then you do the exponent rule for the variable. They're multiplying. The bases are the same. They're both x's. So we're going to add 3 and 5. So x to the 8th. Multiply do the regular math with the numbers in front, and then do the exponent rule with the variable. That's what you want to do here. If they decide to make it real tough, maybe they put something like this: 6x to the 5th, 5x to the 3rd, 2x squared. Got 3 of them there. Rules are the same. I see parentheses, but I don't see any exponents on the outside of those parentheses. So those parentheses just mean multiply in this problem. So if you see parentheses, look for an exponent on the outside. If there's not one, then just do the regular work there. Okay. So 6 times 5 times 2. Well, I know 5 times 2 is 10. 10 times 6 would be 60. So I know my number in the front is going to be a 60. If you unsure yourself, just do the math. 6 times 5 times 2. Hit it. 60. Okay. And then they're multiplying, so we're going to add all the exponents together. 5 plus 3 plus 2. 8 plus 2 is 10, so x to the 10th. Real simple. If, let's do one more that's kind of a little different, but it's just a simple problem. If it's just x times x to the 7th, what's the exponent on this first variable? A 1, yeah. It's understood that there's a 1 there. So when you multiply those two together, you're going to get x to the 8th. So don't forget that that 1 exponent, if there's nothing written there, it's considered to be a 1. Just like if there's nothing in front of it, it's considered to be a 1. Okay. Let's get kind of mix in some of the other rules. Let's do one straight up, like the rule is x to the 3rd to the 5th power. We see parentheses with an exponent, so that tells us, hey, this is a power rule. What's the rule for the exponents? When it's parentheses with an exponent outside, it's multiply. So 3 times 5 would be 15. Your calculator will not do that kind of manipulation for you. TI-84 will not. There are calculators that do, but they are prohibited from use. If you need them to do that, you're paying a whole lot of extra money for things you'll probably never end up doing with them. But there are some calculators that do that. So let's mix in some of the other example F. Let's say we had 2 to the 3rd, so a number with an exponent, and then a variable with an exponent, x to the 4th, and then let's put that to the 2nd power. 2 to the 3rd, x to the 4th, and then that's in parentheses with the 2 outside. So I'm going to do what with them? Multiply. This 2 is going to multiply to both of those exponents. So it's going to be 2 to the 6th power, x to the 8th power. You can leave it like that. If it asks you to go ahead and evaluate that number in the front, we can work out 2 to the 6th power. It's 2 times 2 times, 6 times. Or you can use the calculator. 2 caret symbol to get the exponent. 6. Hit enter. 64. So, or 64 x to the 8th. On labs, I'm good with either way. On the Canvas quizzes, you'll see the answer choices will all be in exponent form or in worked out form. You'll see that out of there. So be able to kind of bounce back and forth between the two different ways of writing that answer. Let's get a 3 to the 5th, n to the 3rd, in a fraction form, and then a 4th power on the outside. Well, what does the 4 on the outside do? Means multiply to all the exponents on the inside. So 5 times 4, and then 4 times 3. So that's going to be 3 to the 20th power, big number, and then n to the 12th power. My calculator may not be able to handle 3 to the 20th. It can get the number, but I don't know. It'll probably, no, it's got enough digits. I thought it might put it in scientific notation because it's so large. 3,486,784,401. Big number. $486. over n to the 12th. Either of those. Big number there, but evaluating it with a calculator, is not too incredibly difficult there. Let's do one more of the fraction style ones. So we had m to the 6th over x squared y to the 5th. All variables on this one. So that'd be m to the what on top?
M to the 30.
And on the
A to the 10. Y.
Y to the what? 5th, because there's a 1 understood right there, remember? So don't forget that. That's the thing you got to remember is if it's plain, there's technically a 1 there. So 5 times 1 would be y to the 5th. And that's where you kind of get caught sometimes if you forget to put that 1 there. So a lot of times when I'm writing those problems down and I see them, I'll go ahead and just put the 1 there so I don't forget it. If it's a plain variable, put the 1 exponent on it, especially when you're doing things related to this particular section. There's one more exponent rule that we deal with, and it's the easiest one of all. It's the 0 exponent. 0 exponent. Anything to the 0 power is equal to 1. Always and forever will be that way. That's by definition, that anything to the 0 power is 1. If you take a big number like 3,846,784 3,846,784,401. That big number to the 0 power equals 1. It always will equal 1. 0 exponent will equal 1. If you times it times 0, it's 0. But 0 exponent will always equal 1. Okay? Anything to the 0 power. MLB draft started last night. I'm a baseball guy, so you take a baseball to the 0 power, it's 1. Anything you raise to the 0 power is 1, always. Okay, so it can have the most complicated exponents and variables in there, but if it's raised to the 0 power, it's going to be 1. Okay, so keep that in mind as you're looking through that particular section. Let's talk about polynomials in terms of a few other things that we deal with in this particular section. Terms. When I talk about a polynomial and its terms, those are the things that are added or subtracted. They're the pieces. Okay, the pieces that are separated with the plus and the minus signs. Okay, that's what the terms are. Okay, so if I ask you how many terms does this polynomial have, count how many pieces are separated by addition and subtraction. That's one of the things that we'll look at in this section. The coefficients. That's the numbers in front of the variables. The degree of a term. So if we're going to look at the degree of a polynomial, but to find the degree of a polynomial, you got to know the degree of each term. And remember, terms are the pieces that are separated by addition or subtraction. You're going to add the exponents. Sum of the exponents on the variables for each term. Okay? Each term is going to have a separate degree. The degree of a polynomial is the highest term degree. Highest term degree is going to be the degree of the polynomial. So we get the degree of each individual term, and then we just pick the biggest one as the degree of the polynomial. Okay. All right. Let's take a polynomial, and we're going to talk about the degree of that polynomial, and then do some naming of polynomials and stuff in this section. Not going to do a ton of. We're not going to solve polynomials yet. Got a ways before we get to that, but we're just going to look at polynomials. How many terms do they have? What their degree is, and all that sort of stuff. So let's start with talking about the degree. So the instructions are: state the degree of the polynomial. Example I. Here's a polynomial: 2x squared plus 5x y to the third minus 6x. Okay. So how many terms does this polynomial have? 3. There are 3 pieces that are separated by addition and subtraction. First piece is 2x squared. Second piece is 5x y to the third. The third piece is the 6x. Now, the degree of each term. What's the degree of the first term? It's the exponents on the variables. You add them together. Well, there's only one variable on this first term, so its degree is this exponent 2. The second term has 2 variables. What's the sum of the exponents on the variables? 4, because this x has a 1 on it, right? 3 plus 1 is 4. And then the third term has an x to the first power, so its degree is 1. The degree of the polynomial and we'll just abbreviate polynomial with poly, would be the biggest one of those. The degree of the polynomial here is 4. So we had to find the three different degrees for each term. Then we just picked the biggest one for the degree of the polynomial. It really is that easy to get the degree of the polynomial. Okay. Let's look at a couple more of those. 4x cubed minus 5x squared plus 6x to the fifth minus 7. Okay, so this one may be an easier one because it doesn't have multiple variables, but it's got how many terms? 4 terms. All right, 4 terms, and we need to find the degree of each of those 4 terms. So the degree of the first term, 3, second term,
2,
next.
5,
What's this one's degree?
nothing.
Nothing, and that would be 0, right? Since there's not any variables, there's a 0 degree on that. Okay, so no degree on that last term. The degree of the polynomial, 5. It is that easy to find the degree of a polynomial. Okay, a really, really simple idea here. Where it gets complicated is when they put more than one variable in there, like this problem. Maybe you got 2x to the fourth y cubed, 3x to the fifth y, x to the 6th y squared. So when they put more than one variable in there, you've got to pay closer attention to the exponents on the variables for the degrees. So we've got 3 terms here, so let's find the degree of each term. First term has a degree of 7. Second term has a degree of. Third one has a degree of 8. So degree of the polynomial, 8. Yeah, biggest one. So really, really simple idea there. Okay. All right. Naming a polynomial is also very simple idea. Really easy thing here. So let's name a polynomial. When you're naming a polynomial, y'all like to use biblical names like Samuel and Joshua. No, I'm just kidding. You name it by the number of terms you have. Okay. Yeah, I have dad jokes. Sorry. I don't have good jokes. Number of terms decides what you call the polynomial. Okay. If there's one term, the name of the polynomial is a monomial. That prefix M-O-N-O, mono means one, right? So we're using prefixes here for polynomials. One term is a monomial. An example of that would be something like just 2x. That's a monomial. It has, one term. No addition, subtraction out of that. So a monomial is just going to be one term. Just a plain number is even a monomial, like 6. That's a monomial. It's just one term. That's all it means. Really doesn't mean anything else about that. We could describe the degree of that monomial if we wanted to. Same idea of what we just went through. So one term is a monomial. 2 terms would be, what's the prefix for 2? Binomial. Example of that might be something like x squared minus 9. That's a binomial. Got 2 terms separated by addition or subtraction. 3 terms, trinomial. Something like x squared plus 7x plus 12. It's a good example of a trinomial. Anything bigger than that, if it's got 4 terms or more, we're just going to use the generic term polynomial. You could, and you rarely will hear a mathematician use something like a quadrinomial or a quintinomial or something like that. You don't hear anybody use that. Anything that's 4 terms or bigger, you're just going to use polynomial out of that. So anything that's 4 terms or bigger. So I'm just going to give an example of something that's got 4 terms. Anything bigger than that, we're going to call it a polynomial. Is all we're going to do. Okay. So number of terms, tell you how to do that. And then simplifying, we're going to do that and then classify or then name it. So let's simplify and name the polynomial. So 2y to the 4th minus 3y squared plus y. That's the first part. Plus 4y to the 4th plus 7y squared minus 6y. So this kind of puts together the simplifying idea that we did earlier with the polynomials that we're dealing with here. I said L and didn't write an L. Okay. All right. So what are the like terms to 2y to the 4th? What goes with this 2y to the 4th? Well, what does it have to be a like term? It's got to have the same letter, and it'd be the 4y to the 4th. This one would be the like term because they have the same base and the same exponent. So when we add those two together, we're just going to add the coefficients, the numbers in front. 4 plus 2 would be 6y to the 4th. Okay. Not going to change the exponent because we're adding. Exponents don't change when you add or subtract. Exponents only change if you multiply or divide. Okay. So we're putting 2y to the 4th together with 4y to the fourth because they both have the y to the fourths. That's what makes them like terms, okay? And then the next piece is a negative 3y squared. Is there anybody else that has a y squared? Yeah, 7y squared. So negative 3 plus, because it's plus sign in the middle here, positive 7 will be positive 4y squared. And if you don't trust yourself, do the math. You know, negative 3 plus 7 is positive 4. So I'm going to put a plus 4y squared. And then the last piece, I got a plain y, and then I got a negative 6y. Those are like terms because the y's have the same exponent. What's in front of this y right here? A 1. 1 plus negative 6 would be negative 5y. And that's the simplified version. What would be the name of that polynomial? A trinomial. Because it has 3 terms. Let's do one more. We'll go to the next section. Negative 8m squared minus 3m cubed plus 4 minus negative 3 plus 7m squared plus m to the third. All right, so be careful here. This one has a minus sign between the 2 parentheses. So you got to keep in mind that you're subtracting out of that. So instead of adding, so be very careful of that. All right, so like terms, I'm going to start with the highest exponent, which would be m to the third. So I'm going to put those together first. That's not necessarily the way you have to do it, but I think it's a good habit to start getting into because later on when we start solving polynomials, you want them in order from biggest to smallest. So I'm going to start with the m cubes. What's a like term with m cubed or 3m cubed? That 1m cubed there. I'm glad you said the 1m cubed. All right, so negative 3 minus 1 would be negative 3 minus 1, negative 4 m to the third. So I'm used those. I'm just going to mark them out because I've used them. Then I'm going to go down my exponent trail here. So the next piece should be the m squareds. So I have a negative 8m squared, and it goes with the positive 7m squared. So negative 8 minus 7. Negative 8 minus 7 be negative 15 m squared. And then I have 4 minus negative 3. 4 minus negative 3. Positive 7. So a plus 7 because it's positive. And there I have simplified that polynomial to make another trinomial. Because it has 3 terms. The minus sign in the middle there, be careful of that. One more simplifying here. It kind of incorporates a little bit of order of operations in it as well, just kind of trying to pull things that we've done before into what we're doing now. So 4 parentheses x squared minus 3x plus 7 minus 5 parentheses 2x squared minus 8x minus 4. Order of operations would tell us that we need to do parentheses, exponents, multiplication, division, left to right, and then do the adding and subtracting. Inside of each parenthesis, are there any like terms inside of this first set of parentheses? No. Are there any in the second set? No. Can't do that. So I'm going to move on to the next thing, which is exponents, and there are no exponents on the outside of those parentheses that I can work out. So I'm going to move on to multiplication and division left to right. So I'm going to multiply. What does this 4 multiply to? That's exactly right, to everything that's in parentheses. So technically, what's in front of this x squared right now? Right, what's right there? A 1. So when you multiply, you're distributing this 4 to everybody that's in there. So that's going to be 4x squared. 4 times negative 3 would be negative 12x. 4 times 7 would be 28. What are we distributing on the second set of parentheses? A negative 5. Very good. You're distributing that sign with it. So it's a minus 5 that you're multiplying to everybody. So negative 5 times positive 2 would be negative 10x squared. Negative 5 times negative 8x would be positive 40x. Negative 5 times negative 4 is positive 20. So we've done that multiplication so that we're distributing everything. Now we can add and subtract like terms, because the order of operations tells us the next thing to do is add and subtract. So like terms got 4x squared, and it's going to go with the negative 10x squared. So 4 minus 10 would be negative 6x squared. Be a negative because the 10's bigger. If you don't trust yourself, you got the calculator you can help yourself with. So that's 4 minus 10. Just using the sign that's in front of it. And here we have a negative 12x and a positive 40x. So I'm just doing negative 12 plus 40. 28x positive, so it's positive 28x plus. And then 28 and 20, that'd be 48. And how would we classify, what would we name that polynomial? A trinomial again. No surprise that with most of our answers were trinomials. We will spend the biggest part of our time when we're dealing with polynomials working with trinomials over the course of this class. And 110 gets a little bigger than this, but a lot of this class is spent with trinomials. So that's why I use a lot of them in examples there. But again, you're only going to name monomials, binomials, and trinomials. Anything else is called a polynomial. Okay. All right. So that's our section on polynomials. Let's go ahead and do the section on rectangular coordinates and talk about plotting points on a coordinate plane and see where we get from there. Okay. So next section, I'm just going to continue, and I'm gonna use some graph paper here. You don't necessarily have to have it. I'm just going to use it because it kind of helps you be able to follow where I'm at with that. So if you've got graph paper, you are welcome to use it, but you don't have to have it for what we're doing here. So you can kind of see the grid that's going on there. So we're getting out of that review section and getting into the skipping over into chapter 2, section 1, and talking about rectangular coordinates. Coordinates. All right. When you're dealing with rectangular coordinates, let me grab a straight edge from my bag real quick. Rectangular coordinates, what we're talking about are ordered pairs. So we'll start with that. Ordered pairs. Ordered pairs, always x comma y. X is in the front, y is in the back. And if for some reason, somebody used different letters, it's always alphabetical order. So if they used A and B, it's A first, B second. Okay. So straight decent grid here. When you're dealing with rectangular coordinates, we're talking about the coordinate plane. There are two axes there. You have the x-axis, which is the one that goes left to right, and the y-axis is the one that goes up and down. X is left to right, y is up and down. Okay? There are 4 quadrants that you deal with. The quadrants start in the top right, and they use Roman numerals to number them. Quadrant 1 is in the top right. Quadrant 2 is in the top left. Quadrant 3, the bottom left. And quadrant 4 is the bottom right. So it's a counterclockwise numbering system for the quadrants. The quadrant just means part of 4. The ordered pairs in each quadrant are certain way. In quadrant 1, the x values are positive and the y values are positive. It's both positive in quadrant 1. So your ordered pairs, if you've got positive, positive, you know it's in quadrant 1. You don't even have to look at the grid to know that. Okay. If you're in quadrant 2, the x values are negative and the y values are positive. Okay. And the reason that's the case is because this middle point here is 0, 0. So when you cross to the left here, these points are negative x values. These to the right are positive x values. If you go up, these are positive y values. If you go down, these are negative y values. So in quadrant 3, that's where they're both negative. And in quadrant 4, it's positive x values, negative y values. Okay. So with knowing, if you just know that and have that picture in kind of in your brain there, you can look at an ordered pair and say, like for example, where is 6, negative 3? Just by knowing, hey, that's a positive x and a negative y, then I know that that's in quadrant 4. Quadrant 4 because if I plotted that point, positive 6, negative 3, I would start here at 0, 0, and I would move 6 spots to the right to positive 6. 1, 2, 3, 4, 5, 6. And then I would move 3 spots down from that point to the negative 3. And that point is right there. Being too still. Lights going out. Room over there. So quadrant 4, positive x values, negative y values. If we plot the point, it gets there too. So knowing this is kind of a shortcut of knowing where something is instead of having to draw it out and plot it every time. Okay. You still need to be able to plot points. We're going to do that next. But know the quadrant rules, like that positive, positive is in quadrant 1. Negative, positive is quadrant 2. Negative, negative is quadrant 3. Positive, negative is quadrant 4. If you know those shortcuts, it can speed things up for you when you're doing that particular kind of work out of that, or you know kind of where to go look for that ordered pair at. So we're going to plot some points on the coordinate plane next. Let's plot the points on the coordinate plane. Coordinate plane, you may also hear it called a Cartesian plane. They're the same thing. Cartesian plane, coordinate plane, same thing. No difference out of that. There's some other different kinds of planes that if you go to higher maths, they plot points on. We use the Cartesian plane in math 100 and 110 only. We don't use the others. Okay, so I'm just going to list out some ordered pairs, and we're going to draw a grid and plot them. So point A, I'm going to put a letter beside them so we can just, and then point B with negative 3, negative 5. Point C, 0, 3. Point D, 3, 0. Point E, negative 4, 2. And let's do one more. Point F, that special one, 0, 0. Okay. So I'm going to take, and I'm just going to draw a coordinate plane over here on the right on my graph paper. If you don't have graph paper, just make straight lines as best you can. And then try to draw out, like, put little tick marks. And try to be as even as you can as you go along there. You don't have to have graph paper to get your points in the right area. Concept is what we're after here, not necessarily. On labs, the grid will be drawn for you. You can use those very easily for that. All right, so I'm going to plot those points, and I'm also going to tell what quadrant or where it's located at over here by the ordered pair. So point A is 2, 5. So I'm going to always start at the origin, which is right here in the middle where the X and Y axis cross. Okay. And I'm going to go X first. So left and right first. So it says positive 2. So I'm going to go to the right 2 because that's positive. And then I'm going to go positive 5. So that's up 5 from that spot. 1, 2, 3, 4, 5. And there I'm going to put my dot, and I'm just going to put the letter A beside it. What quadrant is letter A in? 1. So I'm just going to put the capital I beside it for quadrant 1. Let's do the same thing for point B. So it's -3, -5. So I'm going to go to -3. So 1, 2, 3. And then go down 5 for -5. 1, 2, 3, 4, 5. And there's my point. Put the letter B beside it. What quadrant is that letter B is in? 3. Because remember, they number 1, 2, 3, and 4. Okay, counterclockwise numbering system for the quadrants. All right, quadrant or for point C, it's at 0, 3. So these are sometimes the ones that are confusing to folks because 0, 3. Again, I'm going to start at the origin at the point where they cross, and then I'm going to go 0 in the X direction. So that means I don't move left or right at all. And then I'm going to 3 on the Y direction. That's a positive 3. So I'm going to go up or down? Up. I'm going to be right there. And that's where point C is at. Where is point C located? Is it in one of the quadrants? No, it's on the border, right? And that border is called the Y-axis. So if you're on the Y-axis, you're not technically in any quadrant. You're in between. So it's like standing in the doorway. You're not really in the hallway. You're not really in the classroom. Okay. If I do point D, 3, 0. Go over to 3 here. Put that point there. Where's that located? Well, it's on the what axis is that it's on? The x-axis. It's not really in quadrant 1. It's not really in quadrant 4. It's on the border, which is the x-axis. Okay, so you can be on an axis. That can be your location. Point E. So I would start at the origin again, go to -4, up to 2. And there it is. And that one is obviously in a quadrant. It's in quadrant 2. And then point F is the special one. 0, 0. Hey, that's where I start every time. The name of that is the origin. Okay. Remember that special name for that point. 0, 0 is the origin. Okay. Being able to write plot points on the coordinate plane is very handy. The reason it is handy is because we might need to use that in order to graph some equations later on. Okay. Let's say they wanted us to graph y equals 4x minus 1 and they gave us some x values to use. Okay. If they give you x values, that means you can find y values. That's kind of the idea here, is that we can take -2 and we can evaluate this for when x is -2. So we would work out 4 times -2 minus 1. And you can use the calculator to help you do that. 4 parentheses -2 minus 1. Close those parentheses on the -2 there. And then I get a -9. So I get this ordered pair, -2, -9. And then I would work out 4 times -1 minus 1. 4 parentheses -1 minus 1. Get a -5. And 4 parentheses 0 minus 1. Well, I know 4 times 0. That's 0. Minus 1 is going to be -1. So I don't even have to use the calculator to help me with that one. And then 4 times 1 minus 1. That's going to be 4 minus 1 is 3. And do that without a calculator. 4 times 2 minus 1. 7. So I get these ordered pairs. They gave me the x values to use. So I just plugged them in and got 5 ordered pairs here that I can graph by just using the coordinate plane. Call that better. So I'm just going to plot these points. I don't have letters to put beside them. I'm just going to put the dots there. So I'm going to start at the origin. I'm going to go to -2 and then down to -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a dot right there. And then I'm going to do the next ordered pair, -1, -5. So I go to -1. 1, 2, 3, 4, 5. 0, -1. Don't move at all. Just go down to -1. 1, 3. Over 1, up 3. 2, 7. 2, 1, 2, 3, 4, 5, 6, 7. And there I get all those points making that graph. I could connect them with a line if I wanted to there. Getting those ordered pairs is just plugging in and working it out, evaluating the expression for what x values they give us out of that. And get a kind of a picture of what's going on there. Doesn't necessarily always have to be a straight line either. There will be some of them that will be curved or just different shapes out of that. So don't think that it has to be a straight line when you're graphing those. You're just getting some ordered pairs and plotting points. That's the practice that we're after here. Out of that. Okay. All right. Let's. It's 12 o'clock. Let's